Okay, so this is a hardware. You open the hardware from the hardware panel. Okay, you open a system information from the system information link. Okay, I'll show you this all navigation bars in the later things. Okay, then we'll move on to the data mover. Information about the data mover. The data mover shows that which data mover has been configured. So by default, the system comes with because it is less than 4 GB RAM. This has only one data mover, and the name of the data mover is server underscore two. Okay,
Mm-hmm.
this is a mocked up data mover. Means within the control station only they have built a data mover. This is acting data mover. Okay. See the status, the CPU usage, the memory usage. There is no second, there is no standby. Unicode enable. If I mean you just as soon as you configure, just make sure that you enable the Unicode for iSCSI and CFS configuration to enable it. Boot time, uptime, and NTP server. All this information. Okay, this is the one configuration change you need to enable as soon as you log into the data mover. So what is a data mover? Data mover is our NFS system. It is going to enable the NFS protocol, right?
Mm-hmm. Yeah.
I'll say apply. If there is one more data mover, then there would have been a failover policy enabled there as well. Okay, I'll show you one system where we can deploy two data movers in an enclosure. Okay, so I'll close. Then the next part, the networking part. Okay, so you can see there are two virtual interfaces named EL30, EL31. Okay, these are the virtual devices that emulate a data mover, that signify a data mover. Okay, in a real system you would see same interfaces, same kind of environment, saying that but this will be ETH0 and ETH1 of your data actual data mover. Okay, same way. So it's similar to the original one. Here they are named it as EL30, EL31. There you would have the data mover IPs as ETH0, ETH1 as such. Okay, those are the interfaces. This is a connecting device. This connecting device connects to your data mover to your interface, physical interfaces. Okay, I'll show you how that is made possible. Network services. So these are the services that are enabled on the system: CIFS, FTP, NDMP, NFS file locking, your SNMP, TFTP. All these services are enabled based on the system where they are enabled. Some are enabled on control station, some are enabled on data mover. Okay. Is the DNS configured on the system? Yes, there is acutelearn.net configured on the system for the data mover. Routes, routing entry, it's like from the data mover interface you are going to authenticate these interfaces, these virtual interfaces, right? So
Mm-hmm.
128, 121, 1254. These are the routing. Basically, I want to route from your physical NIC to the virtual NIC. Routing is made possible. Okay,
Mm-hmm.
so So as part of the interface, we have only the virtual interfaces. Okay. Now let's try to create a data interfaces for us. Okay. You remember we have two NIC card enabled on the system, two network interface card enabled on the system. One we have already used it for, okay, one we have already used it for management purpose. Okay, second, let's try to configure it for data connections, means data path. Okay, so for this we need additional IP address. Let's try to check which is a free IP address. Actually, I should borrow this from my administrator, but if I start, like now, if I start the conversation, it will take time and he has to allocate me. So I'll pick up one free IP addresses from the system. 174 is IP which is free. Okay, probably I'll release this once I don't use it. Okay, now as part of the first creation step, I need to configure the physical interface which should interact as a data interface for me. Okay, you understanding what step I'm doing?
Say that again.
I'm creating a physical interface which should connect to a logical component, logical infrastructure of this system.
Okay.
Okay, so it would be connecting to the CGE0 device data mover. Okay, I'll give 192.168.1.174 is the free IP that I was using, right? Ping 192.168. I want to make sure that there is no IP address clash, so I'm trying to ping it once again. Name of this interface, I'll call it as physical NIC. Okay, so this physical NIC is a bridging entity between this virtual device CGE0 and this IP address. Okay,
Say that again.
this physical NIC card which I'm creating, which I'm enabling, okay,
Mm-hmm. Mm-hmm.
is a bridge between this device, this virtual device,
Oh, okay.
and my physical interface. So it's something like this.
Oh, okay, okay.
Okay, so this is my system. Okay, this is my physical NIC. Okay, and there is a software layer. Okay, this is my software emulated layer. This has created one virtual NIC. So basically virtual NIC in a sense, emulated NIC, we'll call it as an emulated NIC. So this physical has an IP address. Okay, I have not yet assigned the IP address to it. Okay, so this physical has an IP address. Okay, I want to bridge this gap between this. So I want to assign the IP address here, text, right? So I want to assign this NIC 192.168.1.174. Okay, so that it creates a connectivity between this emulated NIC and the physical NIC. So this is my ETH0, ETH0. Sorry, I'm sorry. This is my ETH1, ETH1. This is my CGE0. Okay, so I'm bridging a communication between CGE0 and ETH1. Okay,
Mm-hmm.
so that this NIC card, this ultimately this emulated NIC card connects to my physical switch. It's same virtual concept, VMware concept, how it creates the physical NIC and the virtual NIC, right?
Mm-hmm.
Here we are creating a physical NIC and a virtual NIC kind of connectivity. But
Mm-hmm.
here we call this as an emulated NIC. You're getting the concept.
Yeah.
Okay. So as I have to connect to the external entity, external world, I'm using this interface technique,
Okay.
emulation technique.
Mm-hmm.
Okay. So I'll create this and say okay. So my physical NIC is enabled. Let me see if my physical NIC now pings to the external world. Right, 174, which was not pinging now this NIC is defined on this system. So if you go ahead
Mm-hmm.
and check the system, it won't be shown here. It is being allocated virtually. Okay, internally this our IP is used as a data path IP. Means
Mm-hmm.
all my data path, all my iSCSI and NFS will be accessed via this 174. Okay, to see where is this IP address assigned, there is one utility, cd/opt Blackbird. Blackbird is the name of the software, code name of the software. Okay, I forgot the path. Just hold on a minute. Blackbird emulator. Configuring the system. This document, the second document. Yeah.
Document had everything, huh?
Pardon?
The document had everything.
Yeah, this two document together has, one has the initial configuration, the second has the second set of
Oh.
configuration which I am doing now.
Oh.
Okay, I'll try to combine this both two and bring it to the one, what you can say, bring it to one streamlined display. Okay, server underscore 2 hyphen list. Right, see that
Mm-hmm.
CG0 is directly connected to ETH1. Can you see this?
Yep.
So this CG0 has applied because we have connected. So this ETH1 is a data IP. We configured it to be data IP and we assigned the IP address to this. Okay, and this connects to the
Mm-hmm.
virtual device CG0, which makes it possible for the internal software. This software, what is this Blackbird software? Blackbird
Mm-hmm.
software to connect to the external network.
Okay.
Okay, so this, so we all did it through the GUI. Okay, we created an interface. This is the first step in configuring. Any
Okay.
questions here? You can do the
No,
ping
I'm good.
test. If I mean,
Yeah.
once it is connected, we'll just do the ping test. Ping test to our um, 192.168.1.2 to the DNS server. Okay, to check if, yeah, so the ping is alive. My DNS, I'm able to connect to my DNS, and if I'm able to connect to my DNS, obviously I will be able to connect to the external world as well.
Okay.
I'm not sure if it can ping to the Google IP. That's so. Yeah, I thought so because we have not enabled the name server entity on that. That's fine. Uh, we can also check if it connects to our EXX server because EXX server is our ultimate client.
Right.
Yeah, it can ping to our EXX server 10 and it can also ping to another EXX server 16. So I'm going to use two clients here. One is 10 and one is 16. I'm going to also use one more client, 143. No, I'm going to use 60. I'm going to show you the two. I'm going to show you Windows client, and I'm going to show you two EXX server client. So all
Okay.
connectivity is good. Okay. Fiber
Mm-hmm.
channel, we had only one connectivity to our EXX server. We had a
Okay.
restriction there. On iSCSI, we don't have a restriction because we connect on an external component.
Okay.
Right. Okay. So that's about the networking part, the first step. Okay. You can do the statistics information about, you can get the statistics of the device. These are all monitoring activity. We will do the monitoring statistics or monitoring activity in the later part. Okay. So once you
Mm-hmm.
configure, once you check all the tabs of the system, let's go on to the actual configuration, the storage. Okay. So as part of storage, we have multiple entities. Okay. You can configure it to the file system. You can have a data migration, that is your application. You can emulate this VNX box as a tape library. We'll see that later.
Oh.
You can configure the storage pools, you can configure volumes, you can configure RAID groups. Okay. And also you can configure hot spares on it. Okay. But before
Mm-hmm.
going to the configuration, I would like to show you one thing on the settings tab. Just hold on. That's the setting. I would like to show you, I thought of showing you, but I forgot where that configuration lies. Enabling the services. What are the different services you enable to the system? Okay, that's fine. I'll show you that maybe tomorrow. Okay.
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 Well,
So
this is very, very. Yeah. Are you going to provide me FTP access today? I want to download at least OVA.
yes, I'll provide it. No problem. You can just keep it for
Oh,
download, and for half an hour, 1 hour, you can wait. It will get downloaded. It's
okay.
there. It's there on the FTP. I'll recheck on the documentation. Okay, and share it to you. Okay.
Okay, that'll be good. Thank you.
Okay. So as part of the first step, the first step is the zeroth steps, the planning. Okay. Now we have to again do the procedure that we followed on the VNX, on the Clarion, that is planning,
With
creating a RAID group
plan.
or the storage pool, creating the lunch. Okay. Then here we don't have a concept of storage group. They have removed that because this is advanced version. Here we do a direct LUN mapping or LUN masking,
Oh,
you can say. Okay. But
okay.
the two-step storage pool or RAID group are the same. Either you can go for the RAID group or the storage pool. Okay. I'll show you how,
Okay.
I'll explain you how they are different. Let's see what's there on the RAID group. Okay. You see, there have RAID groups are nothing but the grouping entity. Okay. And the RAID systems. Okay. If you see, there are pre-configured RAID groups on the system. Okay. I'm sorry, because this configuration I cannot show you creating the RAID group. Why I'll tell you, because this virtual system comes up with pre-configured RAID
Okay.
groups. Okay.
No problem. No problem. Yeah.
Okay. But I'll show you what are RAID groups and how they are created. So RAID groups are the virtual entity on top of a storage pool. So VNX follows this path, right? VNX follows a slightly different path than our Clarion. So what VNX does is, it, let's say we have a disk array enclosures, hard disk 1, hard disk 2, hard disk 3. Okay. right? 4 hard disks. Usually on a RAID, what we do is we create a RAID group. This is a RAID group, right? Grouping entity in a Clarion, correct? This
Mm-hmm.
is how we do it. But Clarion follows a different path. VNX follows a different path. What it does is, let's say these are the hard drives and these are the flash drives, HDDs, flash disks. Okay, so VNX follows the system of something called as storage pools. Storage pools are nothing but a similar grouping entities. We create a RAIDs and we configure the storage pools. Okay, these are called as storage pools, SPs. Storage pool one underscore capacity. Okay, so this is called as a storage pool 1, and it's a capacity pool because it is created on the 2 terabyte drive, 2 terabyte SAS drive, 2 terabyte, 2 terabyte, 2 terabyte, 2 terabyte, 8 terabyte storage pool capacity created with RAID 0 or RAID 10 or RAID 5.
Okay.
Okay, similar concept as RAID groups in Clarion, but only thing is that they call this as a storage pool. Okay, this is another storage pool 2 called as performance pool. Okay, this is a performance pool and it is being created with, let's say, RAID 3. Performance pool is created automatically. So these pools are like manual creation activities there, or you can ask it to auto provision. When you enable the auto provision on the VNX system, auto provision is a software. Okay, auto provision or virtual provisioning is a software on a VNX system which will pre-configure your VNX system based on the available drives. It is a software
Okay.
feature. It is taking out the burden from the administrator of configuration, storage pool
Mm-hmm.
configuration. It will see that, okay, I have a SAS drives, I have 2 terabyte SAS drives, create a capacity pool, add it to a capacity pool, add all the SAS drives from all the disk array enclosures, okay, from all the disk array enclosures to a capacity pool.
Mm-hmm.
Okay, and if it is a flash drives, take out all the flash drives in all the disk array enclosures. Let's say there are 2 disk array enclosures with flash drives. Take all those and create one big performance pool. Pool is nothing but grouping. Like we created a RAID groups out of 3 disks, out of 4 disks. Here it will not ask for the how many disks you want to create this RAID or storage pool with. It is going to take whatever the disk available and it is going to create it. Okay,
Mm-hmm.
on top of this storage pool we create a small RAID groups. RAID group 0, RAID group 1. Okay, so this is a virtual entity on top of the storage pool. So we take some capacity out of storage pool and create RAID groups. Okay, RAID group 1, RAID group 2, RAID group 3. Like this I can create different RAID groups on top of different storage pools. So there is one level of virtual storage configuration they have added. Okay, on top of RAID groups, so now there is one more additional step. So the ultimate step is LUN. So a LUN can be created here or a LUN can be directly created here. So LUN can take place in any of the virtual components.
One second. So one can be created on the RAID or the storage pool.
Yeah, LUN can be either created on a storage pool or you can create it on a storage pool you can create it on a RAID group which is created on a storage pool. Both possibilities are
Okay.
there.
Okay.
Got it? These are all virtual entities, how they want to utilize, how they want to use the environment to the best possible way.
Sure.
Okay. Yeah. So let's, based on this concept, let's understand how this system is being divided. Okay. So RAID group, I cannot create it. Let's go to the storage pool section. Okay. Storage pools are also pre-created because this is a simulated Clarion, simulated VNX. The storage pools are what you can say, auto provisioned.
Okay.
Okay, but still I can try to create one for you. Okay, I can create a storage pool. Okay, I'll call it as Arif storage pool 1. Okay, and I can create a storage pool out of this one of the performance pool. I want to use the storage pool. What is the minimum pool size? 18608. I'm going to use this full capacity. I'm just mocking it up. Okay, so
Mm-hmm.
stripe size is 32, number of stripe 4, slice pool volume by default, that's keep all that default. So I'm creating a one storage pool. That's what I have done. I have done the selection. I'll say apply. Okay. Okay, so this, I got my storage pool created with a capacity of 18.178 GB.
Okay.
Okay, this is how you create a storage pool. Okay, this storage pool can be expanded, can be shrinked, and it has all the set of properties you would like to give it. Okay,
Mm-hmm.
so as of now, though I don't have an extended capacity to extend it, I can shrink it. I can shrink it by one volume. I can shrink it by another volume. Okay, don't worry about it. We'll speak about the expanding and shrinking in the later part. So this is the first stage. I create a storage pool like the one I created on the VNX, on the Clarion system. Okay, so if I see the property of it, so this storage pool has been created on volume 107 and volume 108. Okay, volume
Mm-hmm.
107 and volume 108, if you click, it will locate you where these volumes are present. These volumes are basically present on the hard disk drive. Okay, disk 16, disk 13, disk 12, and disk 7 together make up a volume 7.
Mm-hmm.
You're getting it? These are our disk array enclosure hard disks, and this has RAID 5, RAID 4 plus 1. This is on a protection of RAID 5. This is attached to the SPA and the data mover too. You're getting it. There is here there is no clear, because it is auto provisioned volume, auto provisioned storage pool. So every storage, what allocation and configuration burden has been taken out from the administrator. So administrator need not to know which drive it is coming from, where it is configured from. If a pool is created, then this guy has taken from some of the disks, some of the flash disk. So it is a performance pool. It is taken from the performance pool, all the performance flash drives. This storage pool is sitting on the performance pool. That's what you got to understand. It masks most of the backend capability. User just understand there is a storage pool. I need to create a LUN on it. Simple. Any questions?
Oh, good.
Too much complexity, or made very much
No,
easy?
no, no, I'm following you. No, I'm getting it.
Yeah.
I think on the previous version and this one is most of the thing has been auto done, so
Yes.
that's why we don't really see that. But
Yes.
I'm fine.
Yeah, most of the thing is auto done here because they want to remove out the user management is more made very simple as far as possible. User has
Mm-hmm.
to only think about the LUN which he wants the access of. Okay, so here the user is only focused towards getting the LUN, getting the storage space from how it is created, where it is created. No, he need not to bother about. Okay, I'm just showing you, I'm just going back and showing you to see how you can map it on a real physical VNX system, and how it is mapped, how the volume is mapped to the disk, and how the disks are created with various RAID capabilities.
Mm-hmm.
Okay, so I'll speak about the volume as well. Okay, so volumes are created on the entity called as disk. Disk is nothing but the hard disk. Okay,
Mm-hmm.
on which you created. As of now I have two disks. You see this disk number 9 and 10, which are free disks. So let's try to use this disks and create a volume. Volume is one more virtual entity underlining this. Okay, so on a hard disk actually you create a volumes, and on volumes
Mm-hmm.
you emulate a storage pools or the RAID groups. So there are
Mm-hmm.
three levels of virtual entity being created on a physical drives: physical
Mm-hmm.
drives, volumes, storage pools. Okay, so let's create a volume. I'm going to create two volume. What happened? Again, my date got changed. Apply. Okay. So I'm going to create two volumes here on disk number 9. Create volume. Yes. Certificate is valid. Okay. So you create a stripe volume, you create a meta volume, or you create a slice volume. Stripe volume
Mm-hmm.
stripe volume uses a RAID 5, 8 plus 1 drive, or RAID 8. Okay, so you go for the meta. Meta also uses the same. Okay, slice uses a different component altogether. Disk RAID 5. Okay, so there is a so volume can be broken down into a stripe. Okay, a stripe is nothing but a striped volume. Means it spans across two volumes or three volumes or three discs or four discs or five discs. Okay, meta is nothing but where you store the meta information. Okay, you remember the reserved LUN pool. Reserved LUN pool area is a meta volume in a VNX system.
Mm-hmm.
Okay, and a slice part is nothing but a chunk that can be created on one disk, or usually a chunk is nothing but you are again you are dividing this entire what is that, this single disk can be divided into small chunks. That's called as a slice. Okay, granularity, I'm trying to explain you granularity. Okay, this is a slice. Okay. Oh, sorry, this is a, yeah, this is a slice 1, slice 2 on a big disk. On a big hard disk you can create a small slices. Okay, you can create a create a stripe out of multiple disks. Okay, you are striping it, you are giving a larger capacity. And the meta is nothing but meta is a slave. Meta is same as slice. Sorry, meta is same as stripe, but meta is used for particularly storing the meta information. You're understanding the granularity?
Say that again. I think that meta is a little bit confusing. I
Meta,
understand Stripe.
yeah, meta is nothing but it's a slice. Sorry, it's a
Okay.
stripe. Meta is a stripe, okay, but this
Mm-hmm.
meta volume which you create can be only used for storing the meta information, can be used to store
Okay.
only the snapshots, can be used to store
Okay.
only the data transaction information, so that it will be used for, it will be not used as part of any storage pool.
Okay.
Okay, so let's create you want to create a slice. Let's create with a stripe. So for stripe I'll be using two drives, striping across two drives. I'll call it as re re volume for a quick identification. So what is the size you want? Do you want a kb size? This is stripe size. Stripe size 64 by default. I'll keep it as 64. Means the striping capabilities, the striping chunk, how much chunk of stripe you want, chunk number 64 or chunk 128. So I'll keep it as 64. I'll say apply. Please select at least two volumes. Apply. Okay. So RA volume has been created on these two disks, across these two disks, stripe volume.
Mm-hmm.
Okay. Now I can use this stripe volume to create a storage pool. I hope so. Will this allow? Will this simulator allow me? No. I cannot create a storage pool, but I can create a meta volume because there is no meta here. It is not displaying any templates. So this, okay, but I can create a meta volume, the volume which is required for meta information out of this RE volume. Okay, select the volume of single disk type to add a new storage pool. To select an additional item, click Control C. Okay, so let's call it as Arif Meta Pool 1. Okay, out of Arif volume, I'll say apply. Okay, so this I got a 4.4 GB Arif Meta pool. I created a pool out of a volume.
Mm-hmm.
Okay, I created a volume out of the disks. Okay, and I created a pool out of a volume. Three levels: disk,
Mm-hmm.
disk, volume, pools. And on top of pools, you can either create a RAID group or, or directly create a LUN.
Mm-hmm.
You got the what you can say, uh, how each entity is being linked. Okay, disk, on top of disk volume, on top of volume storage pools, and on top of storage pools you can create a RAID groups.
Mm-hmm.
Correct?
Yep.
Okay, that super. So now next step is like what we have now. We have a file systems on top of a storage pools. File systems are nothing but LUN entities. Should we do this file system tomorrow? Is it too much?
Yeah. Yeah, let's do it tomorrow. Hey,
Okay.
I was checking. Can we do the class on Sunday, your Monday instead of tomorrow?